Okay, last time we finished B4. Now we're going to start for P5 algebraic expression.
When is our quiz?
The quiz will be in the end of this class at 7, like 15 minutes before the class end. Okay.
Okay, cool.
So everyone will open the web sign and start doing the quiz. It will be for 15 minutes. It's like 3 or 4 questions, similar to the homework. Okay.
Okay, cool.
Yeah, it's in the web sign. It will be in the web sign, Amanda. Okay. So it will be available last 15 minutes of this class. Will appear last 15 minutes. Right now is not showing in the web sign. The last 15 minutes will be appear, then until the end of the class. Then will disappear again. So again, 1 point, we will start for P5. It's called algebraic expression. Algebraic expression.
I have a question. What if we have a question about the homework? Should we contact you outside of class?
You can contact me by the email or like in the office hours.
Okay.
Fine.
All right.
Okay.
Cool.
So, but before like you for the office hours, you have to like email me to make sure to make the Zoom link to send you the Zoom link. Okay.
All right. Perfect.
Okay. So B5 algebraic expression. What is the meaning of algebraic expression? So algebraic expression, I will give you like a brief for the meaning of this topic. This is mean if I have variables, what is the meaning of variables? It's like look like letters, okay? Like, for example, letter X, Y, Z, W, whatever. And I have real numbers. This real numbers with this variables combined together by operation. So I combining these things to each other, combining to each other by operation, such that like by addition, subtraction, multiplication, or division, or like I use power also, or root, powers, root. All of these makes the algebraic expression. So let me give you example like algebraic expression. For example, something like that. I have like x squared plus 7x plus 4. So this is an algebraic expression. Why? Because we have variables, look, x, and I have numbers, 7, 4, and all of them combined by using operation, plus, and also I have power, look here, too. All of these, this makes algebraic expression. This is called algebraic expression. Okay. Another example for algebraic expression, square root of x plus 5. Look, we have radical root of x plus 5, number, variable, operation, plus, and the root. So this is called also algebraic expression. Also something like that, y minus 7x over like y squared plus 4. Same things, variable x and y power, and we have division. So all of these examples are algebraic expression. So now we know what is the meaning of algebraic expression. Also, we have to know another definition is called monomial. So what is the meaning of monomials? Here. Monomial. So the monomial is an expression look like ax to the power k. So if I see something like that, variable x, a it's a real number, k it's a natural number or 0. This is called monomial. So this is here real number. Okay, and this is here the x is a variable. The k here, it's natural number. The k is the power or natural number or 0. Okay. So who will give me example for monomial? Example for monomial? Give me an example. So who will give me example for monomial?
7x
7x, exactly. What else? To the power what?
to the power 4.
4. Okay, perfect. What else? Or give me another example. Or give me another example.
X plus 5.
X plus 5. But this is look like this expression
Oh, sorry.
is not look like because we have add a plus. This is expression, but this is monomial, not monomial. It's expression here, algebraic expression. This is true, but this is monomial, look like this. No, it's not. Who give me
Square root of x?
Square root of x? Square root of x, it is look like monomial, something like that. No, why?
No, oh my God.
Because this is equal x to the power 1/2. And 1/2, it's natural number? No, it's not natural number. So this is not monomial. This is not monomial. This is not monomial. And this is also not monomial. Who will give me another monomial?
3y to the third.
It's 3y to the third. Yes, exactly. This is monomial because I have real numbers. We have y variable. I have the power 3. The 3 is natural number. Perfect. Here, Christopher, he said 5x to the square. 5x squared. This is true. This is also monomial. Why? I have real number, I have variable, I have also here natural number, the power. What about number 7? The numbers, the real numbers, 7, 8, 20. Yes, it is monomial. Why? Because 7, it's look like 7 times x to the power what? 0. And the 0 here I said k, it's natural number or 0. 7x times to the power 0 is equal 7 because I said x to the power 0, anything to the power 0 is 1. So this is equal 7 times 1, okay? So this is also monomial. Make sense? Any question? Anyone has a question? Okay.
So a number by
So
itself is also a mono.
any, yes, any number, any real number is monomial. Any real number is a monomial. Make it here. Monomial. Okay, hold on 1 second. Okay, so now this is the definition of monomial. Let's go to the second definition. It's called binomial. So the binomial, it's the sum of two monomials. Is the sum of two monomials. What does that mean? Like if I have two monomial plus another monomial. Like who gave me last time this example? Here, monomial x plus monomial. This is called binomial, but it's not monomial. X plus 5, it's binomial, but it's not monomial. So example for this. Who will give me example? X plus 5, like I said. Who will give me another example? So here, x, it's a monomial, plus monomial, it's binomial. Who will give me example for
2x plus
binomial?
3.
X plus 3? Yes. What about something like that? This is binomial. This is binomial. Is the
Yeah,
square root of
yes.
x, is the square root of x binomial? This is monomial here. This one. This. This is monomial here.
No.
No, exactly. Why? Because this is x to the power 1/2. And x to the power 1/2, the 1/2 is not natural number. So this is mean this is not binomial. Okay? So this is not binomial. Another example. What about x squared plus 7 or plus 2x? Is it binomial? Yes.
Yes.
Yes. Why? Because the first term, this thing, is monomial. This is monomial. Here it's natural number, the number 2. Here to the power 1. Actually, it's to the power 1. So this is also binomial. So this is yes, binomial.
Why
Any
did you
question?
cross out? Why did you cross out the one you did?
This one, it's not binomial.
Why?
This is wrong. Why? Because x, square root of x plus 7 is equal x to the power 1/2 plus 7. And 1/2 is not natural number. You see 1/2 here? It's not a natural number. This here, the power must be natural number. The power must be natural number. Okay? Here,
Yeah.
1/2 It's not belong to the natural number. Okay, third thing is called trinomial. So the trinomial is again the sum of three monomial. So the sum of the three monomial is called trinomial. Same idea, same exact idea. Will you give me an example?
Is it x squared plus 3x
Plus-
plus 8?
Plus 8, yes. Who will give me another one? Same thing, 8x to the power 4, for example, plus 7x to the power 2 plus 5. This is trinomial. Will you give me another one?
What
Same
about
idea.
like 4x plus 2y minus 3?
4x plus
4x
what?
squared plus 2y
Square.
squared?
Plus what?
2y
2y
squared minus like 8?
minus 8. We have here different variables. And no, this is not a trinomial. Why?
That wouldn't work?
It's not a trinomial. Why? Because different variables. The variable must be the same. This is not a trinomial. This is wrong. Because the variable must be the same. X, 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 Y, Y, Y. Okay? This is not trinomial. It's a good example, though. So this is not a trinomial. Not trinomial.
Hi, Professor. Question. If you changed that x squared to a y squared, would it be a trinomial?
It will be, okay, another good example. He said if I change like for x squared plus 2x squared minus 8. So we have the same variable. This is actually, I will teach you in this class how to add or subtract trinomial. So this is, but this is equal like 6x squared minus 8. And this term, it's look like have two, this expression has two terms. This is mean it's not a trinomial, it's binomial. Okay. So in this class, I will teach you also how to do summation of two trinomial or binomial or stuff like that. So when you do both of these two terms, the beginning two things, we can add it together and they give me 6x squared minus 8. And this is the binomial. So this is binomial. Make sense? So now the last thing, we will learn something is called polynomial. So this is the biggest things now we will learn it. It's called
I have a
polynomial.
question.
Yes.
You said that the one you crossed out wasn't a trinomial.
It's not trinomial. Why? Because we have different variables. Here we have x, here we have y.
Oh, okay.
It must be, okay? It's supposed to be the same variable.
Got it. All right.
Supposed to be one variable, x squared plus 2x minus 8 or y squared plus 2y minus 8. So polynomial is a sum of of of, of monomial. Sum of monomial. What does that mean? Like any sum of monomial is called binomial. This is mean the binomial it's polynomial. Trinomial it is polynomial. Monomial it is a polynomial. Make sense? So polynomial it's like the biggest set. It's called sum of monomials. So if I have one monomial, I have two monomial, I have three monomial, between them sum, this is called polynomial. So every trinomial it's polynomial, every binomial it's polynomial, and every monomial is polynomial. So I'll give example. Who will give me example for polynomial? Who will give me example?
2x plus 3.
2x plus 3. 2x plus 3. Exactly, this is polynomial. Who will give me another example? Who will give me another example for polynomial? This is what polynomial. Who will give me another example? This an example of polynomial. This, but also these is example for polynomial. So 8x to the power 4 plus 7x squared plus 5, it's a polynomial. So it's sum of monomials. Make sense? Any question? Okay, let's go to the next slide. So now I will give you the general definition of polynomial. So the polynomial is it's an expression of the form an xn plus an minus 1 times x to the power minus n minus 1 plus dot 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 plus a1 x plus a0. What's that? This all the a's here are real numbers, and the n, see the n minus 1, the n is natural number or 0. The n is natural number or 0. Okay, so this is the general definition of polynomial. So I will give you another definition of degree. What's the meaning of degree? So if the term an, this term, if an not equal 0, I mean for an this part here, an, if this part is not equal 0, then the polynomial has degree n. That means it's the highest power of this polynomial. The highest power. of the polynomial. So degree is the highest power of the polynomial. And I will also the definition of terms of the polynomial. This thing here is called term. This thing is called term. This thing is called term. This thing is called term. So the term is a monomial of the form k x to the power k, such that again k it is a natural number or 0. So let me give you example for everything what I said. Any question before I go to next slide for the example? So example. So if I have polynomial and here the type of this polynomial and here the terms and here the degree. First polynomial look like 2x squared minus 3x plus 5. So what's the type of this polynomial? And what's the terms of this polynomial?
Trinomial
Trinomial.
Trinomial.
and 3 terms.
Yes, it's trinomial exactly. Why? Why trinomial?
It has 3 terms.
Exactly. It has 3 monomial. Look, 1, 2, 3. So this is trinomial. What's the terms here? What is the term?
3.
It's not. I ask here, what's the terms? I'm not asking the number of the terms. They are 2x squared, comma, minus 3x, comma, 5. 3 terms. But what they are? 2x squared minus 3x and 5. What is the degree? The degree is the highest power.
2.
It's 2. Look here, 2, 1, and here it has actually x to the power 0. And x to the power 0 is 1. So the degree here is 2, the highest power. Okay, now example number 2. Something like that. X to the power 4 plus 5x. What is the type?
Binomial.
Binomial.
Why it's binomial?
It has
X to the 4. Oh,
There's only 2 terms.
Exactly. Because it has 2 terms, x to the power 4 plus, and the second term is 5x. So it is, what's the term here? X to the power 4 and 5x. What's the degree?
4.
4, exactly. The highest power, look, 4, and here is 1. So 4 is the highest power. Last example. Number 10. What is the type?
Monomial.
Monomial. What's the terms here?
10.
Only 10. What's the degree?
1.
No, it's not
Wait.
1.
0.
0.
0, exactly. Why? Because x actually it looks like 10 times x to the power 0. So the degree here is 0. Make sense? Any question?
I have a question.
What's your question?
So you never count like the one that would be like on the 5x or on the 3x?
In which example? Which example?
I mean, for the both ones, the first two, I'm saying like you see the imaginary one that is on top of the x.
Ah, okay.
So I'm saying it wouldn't be like 3 degree instead of 2.
No, it cannot be 3 degree.
Okay.
Why? Because here the 3, it's not the power. We look into the power. The power, it's like the exponent for the variable. So the exponent for this variable, it's 2. This is the exponent. Okay. So it's the exponent. The highest power is 2 here. Here is 1. Who's the greater, 2 or 1?
2.
It is 2. Exactly. Here the same thing. The exponent is 4. And the second exponent is 1 here. Who's the greater, 4 or 1? It's 4. That's why the degree is 4.
Okay.
10 is equal to 10 times x to the power 0. We have only this exponent, 0. So the degree is 0. So always the degree for any real number is 0. If I see a real number, 10, 9, 7, 8, always I have to know the degree is 0. So in general, make sense? Okay. Now let's go to a polynomial to give you, like, I will give you example and you will tell me this is polynomial or it's not polynomial. You have to choose which one, which of these are polynomial and which of them not polynomial. So which of this is polynomial? For example, first one, 2x to the power 4 plus 5x plus 6. Number 2, square root of x plus 10. Number 3, 1 over x plus 5. Which of them is polynomial and which of them is not polynomial? First one is polynomial?
Yes.
Yes.
Yes. Why? Because it's look like as an x to the power n plus an minus 1 xn minus 1 plus plus a1 x plus a0. And here look, the 4 is natural number. The one here we have exponent 1 is natural number. This is called polynomial or trinomial. If you want to specify what's that called, trinomial. And I said trinomial, it's polynomial. Second one, it's a polynomial.
Yes.
No.
Okay,
No.
who said no? Who said no?
I did.
Okay, you did. What's your name?
Emeka,
Emeka. Why it's not? Why no?
because the square root of x is not a real number.
The root of x is not. Is not what?
Is not a real number.
It's not a natural number, right?
A natural number, sorry, not a natural number.
Okay. So, good. Who said yes?
Me.
Who's that? What's your name?
Salim.
Salim. Why you said yes? Like, can you explain how you think? Okay, so I'll explain it for you. So here, square root of x plus 10, it looks like x to the power 1 over 2, right? Plus 10.
Yes.
Okay, Salim, 1 over 2 is a natural number. 1 over 2 is a natural number.
No.
It's not. It's not a natural number. So this is mean x to the power 1 half plus 10 is not polynomial. Okay? Make sense?
No. Yes.
Well, because 1 over 2, 1 half, the exponent 1 over 2 is not in the natural number. What is the natural number? It is 1, 2, 3, 4, 5, 6, 7 to infinity. All like the positive side. 1, 2, 3, not a fraction. We don't have fraction natural number. Okay, now for this one, this is a polynomial or not?
It's not,
Is not. Why? Can you
because
explain
the
why?
variable, it's
What's your
shown
name?
as a denominator.
What's your name?
Herbert,
Herbert. Okay, why it's not polynomial?
because of the variable x, it's the denominator.
Exactly. So how can like express these things in different way? Can you express it in different way? Like I can like move the x from the denominator to the numerator to the up.
Yeah.
How?
You can
What
make
is that equal?
x negative 1.
Exactly.
Yeah.
So this is equal x to the power minus 1. X to the power minus 1 plus 5. And this is not polynomial. Why? Because the minus 1 is not natural number. Make sense? Not polynomial. Why? Because the minus 1 is not belong to the natural numbers. Make sense?
Professor, so would you say that any negative
N-
exponents will be a non or a not
Yeah.
polynomial?
Negative exponent, it's not a polynomial.
Thank you.
No problem. Okay. So now we will, any questions so far? So now we will learn how to add and subtract polynomial. So now we know what's the meaning of polynomial. This is polynomial, this is not polynomial, this is not polynomial. So we learn how the polynomials look like. And we learn also the trinomial, binomial, monomials. So now we're going to learn how to add and subtract polynomials. Adding and so in this here we have to learn. I will start by using I give you example, and from the example I will explain how we can add and subtract. First example said if I have x to the power 3 minus 6x to the power 2 plus 2x plus 4. This is a polynomial, okay? Plus we need to add it to another polynomial. x to the power 3 plus 5x squared minus 7x. So if I want to add polynomial to another polynomial, I have to make a group like terms. What does that mean? Like I'm looking for the variables raised to the same power. So this variable raised to the power 3, and this variable here raised to the power 3 again. So I make both of them as a group, okay? So to solve this thing, I make a group like terms. So this means I make x to the power 3 with this x to the power 3 plus I have here minus x squared, and here I have 5x squared. I make it a group together plus 5x squared plus I open parentheses 2x, make it with this guy minus 7x plus I have number 4. Here I don't have anything, just 4. So this is called the group like term. I make all the variables raised to the same power
Professor,
together.
for the x squared, you didn't put 6x squared.
Oh, sorry. Yeah, here we have minus 6x squared. Thank you. So again, x to the power 3 plus x to the power 3. Here minus 6x squared plus 5x squared, 2x minus 7x, and here we have 4. Yes. So now we combined the like term. That means I have here number 1 in front of the x cube, and here I have number 1 of the x cube. Just I add the numbers. So 1 plus 1 is 2x cubed plus minus 6 plus 5 is, what's the answer?
Minus 1.
6 minus 1x squared plus
5x.
5x
No,
exactly.
negative
No,
5x.
it's negative
Negative 5x.
5x, yes. Plus the number 4 goes down. Again, I remove the parentheses. It will be like 2x to the power 3 cubed. Here plus minus x squared plus minus 5x plus 4. Make sense? Any question? What's your question? Who asked a question?
It was me. I was asking if that was the final answer.
Yeah, this is the answer. This is the only answer. I answer your question? That's it.
Yeah.
Done. Okay. So this is for adding. Now, example for subtracting. Another example. If I have something like that, but the same example, but instead of plus, we have minus. X to the power 3 minus 6x squared plus 2x plus 4 minus x to the power 3 plus 5x minus 7x. Okay, how can I solve it? So first thing, for something like that, I want to distribute the minus inside the parentheses. This is the idea. Distributing the minus inside the parentheses. So what I get is equal x to the power 3, right? Minus 6x squared plus 2x plus 4. Now, distributing the minus, what is that equal?
Minus x to the third
Minus x to the third
minus 5x
minus 5x
plus 7x.
plus 7x, exactly. Now, we're grouping like terms. This means variable has the same power, we put it together. So I have here x to the power 3, and I have here minus x to the power 3, plus, this is fixed, the plus. I have minus 6x squared, and I have here, sorry, here in the example, I have square here, don't forget square. So I have minus x squared minus 5x squared. Okay. Plus, I have 2x plus 7x plus, I have only 4. Okay. So now we combine the terms, okay? How we combine it? Who will do it?
I can do it, Professor.
Yeah, what is the answer?
So the x squared minus x squared will cancel out.
Cancel out, exactly, 0. Plus, minus 6 minus 5 is
So it'll be negative 11 squared
11x
x
squared,
squared
exactly. Okay,
plus
Plus.
4.
7 plus 2 is, don't forget this one.
Oh,
2x
sorry,
plus 7x.
8x, 9x
9x, exactly. Plus the 4.
plus 4, yeah.
Okay, so what's the answer? I want to remove the parentheses. It's 11 minus 11x squared
Plus 9x plus 4.
Okay. So minus 11 x squared plus 9x plus 4. This is the final answer. Any question? Any questions so far? How to add and subtract polynomial? Okay. So now let's go to the multiplication. How we can multiply polynomials. So multiplying algebraic expression. Okay. So I will start by using like example to explain this idea. For example, find the multiplication of this two polynomial 2x plus 1 times 3x minus 5. So here we will use the idea for distributing a property from the first section in this book. That means we distribute this one by all this term and the one by all this term. Who will do it? all the terms 3x minus 5 plus 1 times all the terms 3x minus 5. And this is equal multiplying the first one by everything inside. 2x times 3x minus 2x, no, plus, I mean, times minus 5 plus the 1 times everything inside is the same, 3x plus minus 5. Now we simplify it. 2 times 3 is x times x is x squared plus 2 times 2x times minus 5 is minus 2 times 5 is 10, x plus 3x here again plus minus 5. Okay, and this is equal. Now combining like terms. Okay, so what is that equal? 6x squared minus 10 plus 3 is minus 7x. And we keep this alone, minus 5. Any questions so far? Anyone has a question? So we're using the distributive property, like first things in the book, in this chapter, in the first chapter. I give you another example. It's no question. How we can solve something like that? 2x plus 3 times x squared minus 5x plus 4. Who will do that? Same idea like before. We're distributing everything to this second parenthesis. Anyone will do it? Yes.
I'll do it.
Yes. Okay.
So that'll be 2x squared.
Can you
X to the
explain how you
third.
do it?
X to the third. So you
Okay, so
gotta, yeah,
no, I mean, like, can you do it like here, step by step?
sure. So 2x
Times
times x squared
minus 5x.
minus 5x plus 4.
Exactly. Then plus what?
3 times x squared
Okay.
minus 5x plus 4.
Okay. Then what do you do? Distribute this again.
Distribute, yeah.
What is the answer?
So that
2
2x to the third
to the third.
minus 5x squared. I mean
2
10x
times
squared
10x squared. Okay.
plus 8x
Plus 8x. This is done. Second term. 3 times this one.
so
Right?
that 3x squared
3x squared
minus
minus
15x
15x
plus
plus
12.
12. Now, polynomial plus polynomial. What is the answer? Like before, polynomial plus polynomial. So we do group terms, 2x to the power third It's alone. We don't have any variable to the power third. So we keep it alone, right?
Yes,
2x to the power 3. Then what we have to do?
that's
We have x to the power 2 and x to the power 2 here.
so that's
we do
minus
minus what?
7x squared.
X squared, exactly. And the x, we have plus 8x and minus 15x.
That's minus 7x
Okay,
plus 12.
plus 1. Makes sense? Okay, let me explain. Here we distribute the 2x inside and the 3 inside too. Here we have we make like combined terms minus 15 and minus 10. We have okay 2x this alone. This is with this with this, and this is alone. Make sense? Okay, any question? It's good right now? Okay.
I have a question, Professor. Can you have fractions in this expression?
No, we don't have fractions. Why?
Okay, thank you.
Tell me why we don't have fractions. I mean, like a fraction for the exponent or for the numbers? What do you mean for a fraction for the numbers?
Or like
Or
on
for
that second example, like the first set of numbers, 2x plus 3, can you have 1/2 x plus 3 and
Yes,
then times?
we can do. Same idea, exactly the same idea. Like you mean something like that, right? Like 1 over 2x plus 7 times
7x
plus 1 over 4. So we're doing the same exact idea. And we
Okay, got
learn in last sections, we learn how to add fractions. So in section before the previous section, we learn how to add fractions. Okay, let's doing this fast. So 1 over 2x times 7x. Now I'm going to change it from 7x to make it 8. And here the 7, I don't need 7. I'm using simple numbers. Yeah, we'll use 8x. Here I'm going to use, for example, 6. So 1/2 x times this thing. So 8x plus 1 over 4 plus, again, the 6 times this parentheses. So again, we distribute it again. This inside. This again inside. But we're going to get 1 over 1/2 x times 8x 1x times 8x plus 1 over 2x times 1 over 4 plus 6 times 8x plus 6 times 1 over 4. We distributed this by inside, the 6 by inside. So what I get? 1 over 2x times 8x is 4x squared y. X times x is x squared. 1 over 2 times x times 8 is 4. Plus 1 over 2x times 1 over 4x 4. So we're multiplying two fractions as we learned in last class. This is equal 1 over what? 8x plus 6 times 8 is 48x plus 6 times 1 over 4 is 6 over 4. I can simplify this by dividing by 2. 3 over 2. Now again, what's the answer? 4x squared 1 over 4 plus 1 over 4, 1 over 8, sorry, plus 48x plus 3 over 2. That's it. Okay. I can add this like last time, but this is like big numbers. We don't need, like I can do it this one. We can do it by cross multiplying. So do it by yourself, okay? I keep it for you as exercise. 8 times 48, this is over 1. 1 times this one, cross multiply, and over 8. So I can like make it easier and keep it for you, equal 4x squared plus 8 times 48 plus 1 over 8 x plus 32. Any questions so far about multiplication? How we multiplying polynomials? Okay, let me give you the last things of this section. It's called special product formulas. Last things in this section. Special product formulas. Who's this in the chat? His name or her name, FUFG. Who's that? So special product formulas. So this is the last thing I'm going to talk about for this section. First thing we have to know, if I have A and B are real numbers, A, comma B, both of them are real numbers. Okay, so if I have two real numbers, so A squared minus B squared is equal A minus B times A plus B. Okay, this is the first formula. So you have to know this one. A squared minus B squared, it looks like A minus B times A plus B. Second thing you have to know, if I have A plus B all of this square, this is equal the first one square plus 2 times the first term times the second term plus the second term square. Third rule said if I have something a minus b square, this is equal to the first term square minus 2 times the first one times the second one plus the second one square. Is good? Makes sense?
It wouldn't be minus b square.
No, it will be positive b square. Just the minus will be in the middle. In the mid. Only here positive, here negative, and everything positive.
Got it.
Make sense? Okay. Any questions so far? So I give you example by using this rule. This is special rule. Example. Okay. 3x plus 5 square. How can I solve this thing? Who will help for this one? By using the second special product formula. So look, this is
3x squared.
okay. What is A? Can you? What is A? What is B? Can you show me what is A?
A is 3.
A is a 3x, right? Is
And
3
that's B.
everything? Yeah. What is B?
5.
5 exactly. So actually, I have A plus B square. How can I solve this one? And by using the second property, said the first letter A square plus 2 times the first times the second plus the second square. So how can you help me for this one? Now, how can I solve this one?
3x squared
3x everything square inside parentheses
plus
plus what?
2
Times the first one
3x
times the second one, right?
5 plus
Exactly.
5 squared.
5 square. How can I simplify this one? Now, 3x everything square is equal what?
9x
X what?
squared
Square. Plus what? 2 times 3 times 5. What is the answer? 2 times 3 times 5.
30x
30
x
exactly.
plus 25.
25. Any questions so far for this one? So this is my A. This is my A times B times 2 plus this is my B here, square. Okay. I'll give you another example before we go to the quiz time. Oh, let me stop until here. Next time I'll give you another example. Okay. So I stop recording for this class. Any question? Anyone has a question? Okay, let me stop recording.